Welcome. I am Juliette Bekkering, Professor in Architecture at Eindhoven University of Technology. I'm happy that hereby I can present you the research we've been doing the last 1.5 years into 3D concrete printing and architecture. In research, we focused on developing a new design instrumentarium that is specific for the concrete printing technique and that could push the boundaries of the so far known possibilities in shape, materialities and ornamentation with concrete in relation to architecture. The research consisted of 2 phases. The first phase consisted of a 1-year research done with a graduation studio with 16 students. And the research was developed at the Eindhoven University of Technology, and the prints were made with a 3D concrete printer in a laboratory of the Faculty of the Built Environment. The second phase consisted of printing prototypes. A selection of results and findings of the 1-year research in the graduation studio have been elaborated and collated into a new final product and summary design for 3 3-meter high columns featuring new aesthetic possibilities in 3D concrete printing. The graduation studio was led by 4 tutors: Kuit, Sjef and Hoof, Zeeshan, Ahmed and myself, Juliette Bekkering. The research was done by many people. 16 students contributed actively to the results. As a test case, we took the city of Ghent as location. The city has many buildings that represent a time when craftsmanship reigned supreme, and facades were ornamented with sculptures and carvings. Today's high labor costs mean that this ornamentation and complex formal language can only be realized in very exceptional cases. However, the 3D concrete printing makes it possible to realize complex shapes and ornamentation, as the printing process makes complicated formworks and labor-intensive machining process superfluous. The question we asked ourselves is how can the richly decorated historical facades of the city become an inspiration for the development of new designs that can be realized with 3D concrete printing? A meticulous analysis of the historical facade fragments was done. Students reinterpreted the fragments using the technique of 3D concrete printing and translated that into new architectural designs that were printed in a laboratory. The goal of the design studio was to allow design and experimentation with the 3D concrete printer to go hand in hand. Prototypes were printed and experiments done. Design by doing. The first starting point was to fathom the possibilities and constraints of the printer and the material. Angles of inclination that could be printed, the straitjacket of the continuous printed line, limitations due to gravity, and the curing process of the material. The second starting point was that the students had to learn the work with a printer, from cleaning the printer to mastering programs that allow parametric modeling such as Grasshopper and Rhino in order to draw 3D models. In order to research the meaning of 3D concrete printing for architecture, the technique itself was researched along 5 parallel individual themes: multimateriality, connections, assembling, supporting material, and patterns. Multimateriality, combining materials, concrete and light. Multimateriality and the potential of working with different materials was studied. In this case, the possibilities of creating a translucent concrete were tested. Glass fibers were introduced in the concrete, thus creating a translucent effect when lights were set on the surface. Glass fibers were in first instance put manually in the concrete. In a later stage, a device could be developed that inserts the fibers in the concrete during the printing process. The result was a concrete artifact that lights up when lights are placed on the inside. The glass fibers guide the light through the concrete and give the concrete a translucent effect, glowing like a lantern. Connection, optimization, 3D concrete printing and flexibility. The subject of the research was a connection and how to print concrete objects can be connected to each other. Elements could form huge flexible walls, bending and bowing walls. In addition, the question was how 3D concrete printing elements can be attached to adjacent elements of different materials, such as window frames, doors, floors, and walls. Different kinds of joints were examined, exploring fixed and flexible joints. A prototype was made with flexible rubber joints. Assembly. The group's research focused on how different fragments can be printed and assembled. Research was twofold. On the one hand, it focused on the development of complex geometries that could be printed. On the other hand, it focused on the way in which the individual elements could be assembled and interlocked to form a larger whole. Support. An important aspect in the use of concrete is the formwork and the way the liquid material is poured into a mold. A range of formwork materials has been tested, ranging from more traditional materials, such as sand and gravel, to more experimental materials, such as printing in glass, beads, gel, liquid clay, and even in yogurt. The results were promising, as double curved surfaces, overhangs, and flowing round shapes became possible. For the artifact, the technique with glass beads was taken as casting material. Because the material tended to collapse after a number of printing layers, a system was devised to print the concrete in a crate, whereby the crate is raised during printing. The crate is continuously filled with glass beads during the printing. The results of the research was a free-form vase in which the limits of manufacturability were explored. In the future, we expect a lot from this process of printing in liquid materials, where strictly speaking full 3D printing becomes possible and the limitations of gravity can be tackled. Patterns in nature. Finding textures and study structural properties. The technique of 3D printing lends itself perfectly to printing different patterns, the principle of the continuous line.
Hi everyone, my name is Alessia Biffi and I will guide you through the next few slides. By studying different mathematical models, we found that a lot of algorithms already studied could help us to fill a region with one continuous line that folds on itself. This was possible by combining two studies, the traveling salesman problem and the circle relaxation. The first one helped us to connect with one single line a certain number of points in a region, according to the shortest path. The second one ensures that between each point there is a fixed distance. This is fundamental in order to ensure that there is a fixed distance between the folding line of the printing path. This is done by making each point the center of a circle with a fixed radius. Through a system of vectors, the circles are moving in order to reach a status of equilibrium, where all the circles are tangent to each other. The radius of the circle, so the distance between each point, can vary by using a color code. In this way, we can fill a region with different sizes of openings. Through these researches, we learned that using supporting material, we can print high elements with large cantilever, and that there is still a large field to discover on how we can improve the aesthetic qualities of 3D concrete printing. In addition, we understood that it's fundamental working with parametric model. After this year of researching into 3D concrete printing, we combined the findings into 3 3D printed columns, which were presented last year at the Dutch Design Week in Eindhoven. This was possible thanks to collaboration between the TUI Eindhoven University, and more specifically with Juliette, Bekkering, Sjef and myself, and together with a 3D printing specialist Vertigo, guided by Volker Ruitinger. We started to investigate on how to design and manufacture 3 columns 3 meters high. The columns are characterized by free-form shapes and different patterns on their surface. The choice of collaborating with Vertigo was fundamental in this aspect. Thanks to their experience and their 6-axis robot, we could reach high detailed printings, thanks to the possibility to print very thin print path. The 3 columns were designed by using the same script and by varying its parameters as height, rotation, and diameters. On the twisted side, a particular pattern were investigated by tweaking the printing path. The starting point was a basic column. By varying its bottom and top and by rotating it, we obtained a twisted column. The column after is sliced in different pieces along the z-axis. Each curve is divided in points. These last ones are moved along a certain direction. By lofting all the curves, we obtain our 3 different columns. Due to the dimension of the robot and our equipment to contain the supporting material, we had to split the columns in 3 parts, 1 meter each. This was also important to ensure the transportation to the exposition location. During the printing process, it was fundamental the use of glass balls as supporting material. This was made to ensure that the cantilever sides were not collapsing. We printed inside of a wooden box that were filled with supporting material during the printing process. Once the print was done, we waited 24 hours that the concrete was drying to remove the balls. For safety reasons, a steel structure were designed inside of the columns, in order to ensure that each pieces were stable on top of each other. And these are the columns presented at Dutch Design Week, and as you can see, there are no protection around them because people could get closer and touch them. In this way, people could also see the high quality and the high detailed printed of our columns and get closer to the pattern that we created on its surface.
The research shows the enormous variety of possibilities that the technique of 3D concrete printing has to offer. Highly detailed shapes were realized and significant overhangs were printed. New patterns and ornamentations can be developed, and a whole new architectural language of complex freeforms is possible. An important new step will be to translate the results of the research into new applications in the built environment. By this, a whole new architectural language is there to be explored. Thank you very much for listening.